If the triple integral over the region bounded by the plane, this is plane 2x plus y plus z is 4, and x equal to 0, y equal to 0, z equal to 0 is given by this expression, then the function lambda x minus mu xy is, as lambda x is involved in this integral and mu x is also involved in this integral. So if anyhow we can find the value which are used, or function lambda x or mu used in this integral, we can easily tell about this. So this is nothing, only the difference. So first 2x plus y plus z is 4. You can write in terms of z 4 minus 2x minus y, or this is, you can write, this is the function of xy. Normally we can write z is a function of xy, and this integral 0 to 2 and 0 to lambda x, 0 to mu xy dz dy dx. As mu xy, this expression is saying that variable x and y used in this integral, so this is the limit of other variable, this is limit of z. X is used here, so this is, because this is the limit of z. And when suppose a house fly is flying in a room and suddenly it sit on a floor, then it simply means that now we are talking about 2D. If housefly at a certain point is flying, then we are talking about three dimensional, and suddenly if say sit on a floor, then we are talking about xy plane, normally 2D plane. So when z equal to 0, then if z is equal to 0, then 4 minus 2x minus y comes in xy plane. This means that 2x plus y is 4. So when z is 0 and this is comes in xy plane and x used here, so this is the limit of y, and this is another, this is constant limit, and left one is x, so this is the limit of x. So mu is the function of xy, so this is the function of xy, so this is not a f of xy, you can write simply mu xy. So this is 4 minus 2x minus y. So value of mu xy we know, and this is lambda x. Lambda x, when we put z equal to 0, so this is z equal to 0. So write function of x, so y equal to 4 minus 2x, so this is the lambda x. So lambda x we have 4 minus 2x. So value of lambda x minus mu xy is equal to 4 minus 2x minus value of mu x used from here, so minus 4 plus 2x plus y. So 4 cancel out by 4, and this again 2x, so value is y. Now which one option is giving the value y? So option D is correct. The surface area of the portion of the plane y plus 2z is 2 within the cylinder x square plus y square equal to 3 is, first, what is the meaning? Surface area of the portion of the plane. This we can find with the help of this formula, square root of 1 plus fx plus fy and square of these, and this is dx dy, or normally we can write dA. xy are coming from the region D. xy are coming from the region D. Here y plus 2z equal to 2. This is the plane. This implies z equal to 2 minus y upon 2, or 1 minus y upon 2. This is z, because we have to find the surface area of this plane within the cylinder. Equation of cylinder in 3D, x square plus y square is r square. This is the normally equation of disk or circle. But when we are talking about this is in 3D, these points make a cylinder, and value of z-axis will be x square plus y square minus r square. This will be the value of z or z-axis. Normally, if there is any plane like this, and we have to find the surface area of this plane within this cylinder, means xy are coming from this disk. So area of disk is normally area of circular region or area of disk. So x square plus y square equal to root 3 square. This is the disk, and area of disk we can find with the help of pi r square, and r is root 3. So pi into 3, it means 3 pi. This is the area of the disk. Now directly in place of dA we can put 3, and we have the value of, so square root of 1 plus partial z with respect to x will be from this, because z is x is not involved here, so partial z with respect to x will be 0, and partial z with respect to y will be minus half. Put this value here, 0 square plus minus half square, and dx dy, and xy is coming from the region or this disk D. So this value is 1 upon 2 square, so 1 by 4 plus 1, and all these are in square root. So because this is free from xy, so you can take outside from the integral. So dx dy, this is 5 upon 2, this is root 5 upon 2, and this is dx dy. Dx dy, it means area of the region or disk, and we already calculated 3 pi. So root pi upon 2 into 3 pi. So value is 3 root 5 upon 2 pi. Now which one option is giving this value? 3 root pi, 3 root 5 upon 2 pi. So option A is correct. Let f is a function from r square to r defined by f of x by this structure. Then the value of this one at the point 0, 0. This is partial or second partial derivative of f with respect to x and y, plus second partial derivative of f with respect to y and x. So what is the meaning of this partial derivative, second partial derivative at a point 0, 0? So f of xy, its simple meaning at 0, 0 is partial derivative of fy with respect to x. You can understand this by as written. So this one equal to limit h tends to 0, because of we are doing partial derivative with respect to x, so normally we take h for x. Fy, this is function 0 plus h comma 0. These are points, as you can understand, a plus h comma b, if we are doing partial derivative at point ab. So we can write like this: minus f of h comma fy 0 comma 0 divided by h. To find this expression or limit, first we need to calculate this expression and this expression. We have two expression to find this partial derivative with respect to x of fy. So first calculate this one. So this is limit h tends to 0. This is nothing but fy h comma 0 minus fy 0 comma 0 divided by h. This is simplified form of above one. So f of h comma 0 is nothing but limit h tends to 0 or you can find here fy 0 fy h comma 0. So call this is a equation 1, or this is principal equation. So fy h comma 0 means partial derivative of f with respect to y. So partial derivative of f with respect to y at the point h comma 0. This is the simplest meaning of this. So write f of h comma 0 plus k, limit k tends to 0, because we are finding partial derivative with respect to y. So normally when we take partial derivative with respect to y, normally we take k, as it is usual, many mathematicians used. And this is f of h comma 0, this at a point value of the function divided by k. And this is nothing but limit k tends to 0 f of h comma k minus f of h comma 0 divided by k, as hk are tending to 0. These are not equal to 0, exact not. So value of this one will be x y square divided by x plus y, means first defining process will give the value of this one. So put limit k tends to 0 and f of h comma k will be hk square divided by h plus k minus f of h comma 0 will be 0. If you put in place of second element 0, then entire expression will be 0 divided by k, and this is nothing but limit k tends to 0 hk square divided by h plus k, and outside you can write k and k cancel out by this. So limit k tends to 0 hk divided by h plus k, this is form. And after taking the limit as k tends to 0, so 0 upon something will be 0. So limit of this one is 0. Means simply we can write fy at 0 comma h is 0. We will put this value in principal equation 1. Now second one was we have to find fy at 0 0, which is used in equation 1, will be limit, because we are finding partial derivative with respect to y. So again take k tends to 0, f of 0 and 0 plus k minus f of 0 0 divided by k, and this is limit k tends to 0, f of 0 comma k minus f of 0 0 divided by k. F 0 0 is 0 and value of first coordinate is 0. So if you will put in this expression, then because function is defining like that, x y square divided by x plus y, if one coordinate is 0, by numerator terms it will give you value 0. So 0 upon k equal to 0. So fy at 0 0 is 0. Call this is equation third. So use equation 1. Therefore f xy at 0 0 is equal to limit h tends to 0, and what we have done here, as you can see, this is equation 1. Value of first expression, this expression is nothing but 0, and value of this expression is again 0. So 0 minus 0 divided by h. So we obtain 0 minus 0 divided by h, and this is equal to 0. So f of xy 0 0 is 0. Now asked about f of yx, fyx at 0 0. Same process here we have to find, because we are going to find the value of del 2f upon del x del y plus, sorry, partial x partial y plus partial second partial of f over partial y and partial x. Now calculate this one. So meaning of this is, you can understand, partial derivative of f with respect to y, partial derivative of fx with respect to y. This is the meaning. So you can write limit, because of with respect to y, k tends to 0. Simply write k tends to 0, and function is fx. So fx 0 comma 0 plus k, because point is 0 0, minus fx at 0 0 divided by k, and this is limit k tends to 0, fx 0 comma k minus fx 0 0 divided by k. Call this is second principal equation, so call it q, and as we find earlier, we have to find this one expression and this one. First fx at 0 comma k will be limit h tends to 0, because we are going to find with respect to x f of 0 plus h comma k 0 plus h comma k, because point is 0 comma k, minus f of 0 comma k divided by h, and this is limit h tends to 0 f of h comma k minus f of 0 comma k divided by h. This will go to 0 by the defining way of the function f of xy. One coordinate is 0 because function is defined as xy square divided by x plus y. If one coordinate is 0, in place of x is 0, then entire will be 0. So it will be hk square divided by h plus k, and you can write h outside denominator. So h cancel out by this one. So left one is k square, and limit is running h tends to 0, k square divided by h plus k. If h tends to 0, then this limit will be k square upon k, and this is equal to k. Similarly, we have to find fx at 0, 0, and this one equal to limit h tends to 0 f of h comma 0, or 0 plus h you can write, minus f of 0, 0 function at the point divided by h. Both coordinates are 0, so this term will go to 0, and this one again go to 0 by the defining structure of function. So limit is 0. Now put all these value in equation q. So equation q implies f of yx at 0, 0 will equal to k minus 0 divided by k, and k by k is 1. So finally asked about this one as partial. So we have find means f of xy plus f of yx, and both this value was 0, and this one we have calculated in last as 1. So 0 plus 1 is 1. So at the point 0, 0 this value is 1, so option B is correct. The function of two variable in xy is defined by this has a saddle point at among these. We need to find at which point this function is showing saddle point. To find this or related terms are critical point, stationary point, and local extrema. These are few terms related to these problems or somehow correlated. Each stationary point is critical point, but every critical point is not a stationary point, because critical point is where gradient is 0 or this is not defined, and this will not defined in the sense either partial derivative with respect to x or with respect to y is not exist, or both not exist. But a stationary point is only where gradient of f is 0, means partial derivative means this and this is 0. Local extrema
is point of local maxima or minima. These are few terms. To find critical point, this is condition as explained, and we need to check fx, fxx, fy, fyy, and f square xy and their sign, and fxx, fyy minus f square xy sign of this. For saddle point, this should be less than 0. If this sign is equal to 0 or value of this one is 0, then need to investigate further. If this is greater than 0, then point of extrema means either minima or maxima. That will depends on the sign of either fxx or fyy. If one of them or both is negative, then point of maxima. If positive, then point of minima. Now come to the concern as saddle point. Function into variable is given by 3x square y plus 4 y cube minus 3x square minus 12 y square plus 1. So first partial derivative with respect to x will be 6y x plus 0 minus 6x and again 0. Fxx will be 6y minus 6. Fy will be 3x square plus 12y square minus 24y. Fyy will be 6x fyy, because this term is not containing y, so this will be 0. 24y minus 24. As this is fx, so fxy means again differentiate this one with respect to y, 6x only. For a extrema point, put fx equal to 0 and fy equal to 0 where both are 0, not only one, both is 0. So fx is 0, it means 6xy minus 6x is 0. This implies 6x as common, y minus 1 is 0. This implies x is 0 or y is 1. Now fy is 0. This implies 3x square plus 12 y square minus 24 y is 0. Now from this one, because we need to check where both is 0, then substitution will help you to find critical points. Put x equal to 0 in this one, then 12 y square minus 24 y is 0, means take x from this point, from this equation as 0, and value of y what are coming from this one. So 12 y is a common, so y minus 2 equal to 0. So y is 0 and y is 2. So value of is 0, and when I put x 0, then I also obtain value of y is 2. So 0 and 2 are y coordinate. So these two are points. Now When y is 1, put in this one. Then 3x square plus 12 minus 24 is 0. This implies 3x square minus 12 is 0. Take 3 as a common, x square minus 4 equal to 0. This implies x equal to plus minus 2. When I put y as a 1, then value of x is 2, and when I put y is 1, value of minus 2 also. So these 4 points are my critical point. Now we need to investigate derivatives, either partial, first order partial derivative or second order partial derivative at this point. So partial derivatives are here. So going to be check partial derivative. At 0 0. First we are going to check at 0 0. Fx x into fyy minus f square xy at 0 0. So at 0 0, f put 0 here, this one will be minus 6 into fyy, put 0 here, so minus 24 minus x square, so 6x whole square means 0. So this value is positive. Now at this point 0 comma 2, 12 minus 6, 48 minus 24, this value is again positive. Now 2 comma 1, 6 minus 6, 24 minus 24 minus 12 square. 12 square is 144 and this is 0, so less than 0. And again 0 comma 2, again minus 2 comma 1, value is less than 0, so these are saddle point. So 2 1 and minus 2 1 are saddle point. What are saddle point? 2 1 and minus 2 1 are saddle point, but given option is only minus 2 1, so option D will be right choice.
Consider the vector field f r raised to the power beta. This r is a mode of position vector as this, where beta is real number and r is this. If the absolute value of the line integral this along the curve, this circular or disk oriented counterclockwise is 2 pi, means mod value of this integral is 2 pi, then value of beta is, as vector r is x I hat plus y j hat, so its derivative or dr cap d vector r will be dx I hat plus dy j hat. This is position vector we normally know, and we have to find f dot dr. So it will be along the curve C, as C is x square plus y square, and vector f. What is vector f? R raised to the power beta, r raised to the power beta, and what is r? R will be x square plus y square raised to the power half, and beta is also, so beta by 2, and this is dr, sorry, r raised to the power beta y I hat minus x j hat with dot product dr, means dx I hat plus dy j hat, and in the dot product we can solve easily. This is x square plus y square raised to the power beta by 2, and this will become y dx plus minus x dy. So we can write this one in simplified form, as curve is given x square plus y square is a square. This is the equation of disk or circular disk, and if we understand, this is equation of cylinder in 3D, but this is a curve, so this is equation of disk. It will be a raised to the power, because this is the value of a square, so it will become a raised to the power beta y dx minus x dy, because x square plus y square is equal to a square. We used this fact. As curve C is x square plus y square is a square, and this is the equation of disk. So we parameterize this equation, x equal to a cos theta and y is equal to a sin theta. Using this, dx will become minus a sin theta and dy will be a cos theta. Use this in above equation. This is equation 1. Now, so it will be f dot dr will be a raised to the power beta. This is a constant value, so you can take outside the integral, and because circular disk, so theta is from 0 to 2 pi, 0 to 2 pi, a square sin theta minus sin theta d theta minus cos theta into cos theta d theta. You can put these value in equation 1 and obtain this last line. Now there is nothing to solve, only we have to simplify this calculation. A raised to the power, take a square common from take a square outside from the integral, so a raised to the power beta plus 2
0 to 2 pi sine square theta plus cos square theta. Also take negative outside, d theta. And this is identity. So minus a raised to the power beta plus 2, and this is 0 to 2 pi d theta. So value of this integral will be 2 pi. So finally we obtained minus a raised to the power beta plus 2 into 2 pi. And it is given in the starting or in hypothesis, absolute value of this f dot dr is 2 pi, and we obtain this value is minus a raised to the power beta plus 2 into 2 pi, and this is equal to 2 pi. Now this absolute value will become 2 pi when value of this one will be 1 or either minus 1. So when we will get value of this expression is 1 when exponent of this one will be 0. So exponent will become 0 when beta is minus 2. If beta is minus 2, so a raised to the power 0 will become 1, and absolute value, because this is either negative or positive, absolute value is will become 2 pi. So value of beta is minus 2 we obtained from this last stage. So option A is correct. Let yx be the solution of the differential equation this, and the given condition is y1 equal to 0 and dy over dx at x equal to 1 is again 0. Then y2 is means value of 2 we have to find as d over dx x dy dx equal to x. This is a differential equation as given. If dx is there and when we take integration of this one, so integration x comes, so this is differential equation. So take integration both side, so it will be x d over dx equal to x square upon 2 plus c1. This is constant, integration constant. Now dy over dx at x equal to 1 is 0. So put this value. So dy over dx is equal to x upon 2 plus c1 upon x. Put x equal to 1 and y equal to 0. Sorry, x equal to 1, dy upon dx is 0. So this is 0, this is half plus this is c1. So value of c1, this implies value of c1 is minus half. Now again separate, use variable separable method. Dy equal to x upon 2 dx plus c1 upon x dx, or you can write like this, x upon 2 plus c1 dx, and this is dy. Now take integration, so it will be y, this is x square by 4 plus c1 x plus c2. This is constant of integration. Now put the condition y1 is 0, so this is 0 equal to 1 upon 4. This one was c1 upon x, so log x, it will be log x. So 1 upon 4 plus, when we put the value of 1 in place of x, So log 1 is 0. So this is C2. This implies C2 is minus 1 upon 4. Now we have the value of C1 and C2 and solution. This is solution y equal to x square upon 4 plus C1 log x plus C2. This is x square upon 4. Value of C1 is half log x and C2 is minus 1 upon 4. We have to ask about value at 2. So y2 will be 2 square is 4. So 4 upon 4, this will be 1 minus 1 upon 2 log 2 minus 1 upon 4. So it will be 1 minus 1 upon 4. So 3 upon 4 minus 1 upon 2 log 2. Now which one option is giving this value? 3 upon 4 minus 1 upon 2 log 2. Option B is correct. Let S is a subset of R and ds denote the set of points which are real numbers such that every neighborhood of X contains some points of S as well as some points of complement of S. It means del S is that set which contains some points of S as well as S complement, and neighborhood of points, real points, which contain some points of S as well as some points of its complement. So this set is nothing but boundary set or boundary points. Boundary points. Suppose this is a disk. So each boundary points means this black arc is the boundary of this disk. So each neighborhood contains some points outside the disk and inside the disk. So this set del S or partial S is nothing but boundary points. So we have to check, and S bar is closer of S, then which one of the following is false? Means we have to seek false statement only. So we have to check each statement one by one, and remember one point: if a statement is true, then it is always true. If it is a false, then it is always false. Means if a statement is particularly true, that means that it is true. If particularly false, that means it is false statement. So first option is partial q is R, means boundary points of q is R. Means any point, suppose x is a point which is in the form p by q, then every neighborhood of this contains some points are rational and irrational, means complement as well as rationals, sorry, irrational as well as rational. So del q is equal to R. This is perfect, means boundary points of q is R. Now option B, as T is a subset of R and it is proper subset of R, then boundary points of R difference T is boundary points of T. So for this, suppose this is real line, this is 0, and this interval is T, this interval is T, then this endpoints are boundary points of T. So boundary points of T is only endpoints A or B. These 2 points are boundary points of this set, and boundary points of the boundary points of R difference T will be, one is this and second is this. So it is also these 2 points. It means that statement B is true, means A and B is true statement and we are seeking only false statement. So we have to check statement C also. Partial T union V, where U and V, T and V are proper subset of R, and doesn't intersection should not be empty set. So consider T is an interval. Interval is mm, easy one. We can find boundary points easily. So we are consider intervals. So boundary points of this interval is means partial T is only 2 points 0 and 1, and V is half comma 2, it is also interval, and boundary points of this is also these 2 points half and 2. We have to check T union V. So T union V is half is inside of T, it means 0 to 2. This is T union V, and boundary points of this T union V is only 0 and 2. So we have seen that boundary points of union is not equal to individual boundary points. Union of boundary points of individuals means partial T union V is 0 comma 2, and this is not equal to partial boundary points of T union boundary points of V. So and this is boundary points of individuals are 0, 1, half and 2. So option C is false. Option C is false, and we have to seek only false statement. So it is our right choice. And you can also find this is statement D. It is true or false. But once we have checked, once a statement is false, so we have to put this statement because of is given. Helping verb is this statement is word is saying only one statement is true, so you can left to check option D also.